Objective here is to identify the amino acids that participate in, that are involved in these peptides. So I'm going to start us off with part A, and well, we can see we've got some, it looks like an amino acid here. We've got some pieces to it. The first task is to figure out which one is the C terminus and which one is the N terminus. And the reason for that is that we know what order they go in. If I started from the N terminus, I would say N terminus, alpha carbon, carbonyl carbon, N terminus, alpha carbon, carbonyl carbon, and so on until we get to the far end, where instead of saying carbonyl carbon, we would see that it ends up in a COO minus, the C terminus. So first thing to do then, maybe have a look at this and try to decide which end of this molecule you think is the C terminus. Okay, well, I think that I'm hoping you chose this one right here, and that's a COO minus, and that suggests that what we ought to do is work from the right in this list here. C terminus, alpha carbon, N. Let's see if we can find that. C terminus, alpha carbon, N to N. That's a good sign. If this really is an alpha carbon, and it must have an R group hung off it, and there it is. It's got a serine hung off it, so that's good. Now we keep on going. Let's see, after that N there, I must have a C carbonyl, alpha carbon, N. So we go C carbonyl, alpha carbon. Now this alpha carbon's got a cysteine, N, and that's fine. And then one more, C carbonyl, alpha carbon. Now the only N left in the game here is this one right here, and it's kind of a funny looking cyclic R group, but it is an R group, and it's called a prolane. So when we wanted to go name this, actually, if we use the Nancy convention, we would start from the N terminus, and we would call it prolane, followed by cysteine, followed by serine. So it'd be prolene, serine, cysteine. Now I've just, for fun of it, I brought up this molecule in Spartan, and you can kind of see the same features in it. There we have the prolane group, and there's that C carbonyl C, and then there's that next nitrogen right over here, and so on. There's the SH that forms the cysteine group. All right, I'm going to go on to the next one now, then part B. And I'll have you see if you can figure out which one is the N terminus and which one is the C terminus. In this case, it's going to be, it's a bit tricky to figure out which one is the C terminus precisely. So to be safe, you might want to go for the N terminus. Okay, so here we go. Oops, I may as well bring up part B here. And so there is the N terminus. And if that's the case, then what we ought to be doing is looking for this sequence, N, alpha carbon, carbonyl carbon. So let's see if that works. We got N, that would be an alpha carbon. Does it look like an alpha carbon? Well, it's got this group off here, which is definitely an R group. And then we have the carbonyl carbon, so that's good, right? N, alpha carbon, carbonyl carbon. Let's keep on going. N, alpha carbon, carbonyl carbon. Now you probably know the name of this R group. That's an alanine because it's just a CH3. And now we'll go N alpha carbon. Now it's a bit tricky here, right? Because I see a COO minus over there and a COO minus here. Which one really is the C terminus? Well, it's got to be the one that doesn't that's directly bonded to the alpha carbon, so this must be the C terminus, and that makes this piece right here the last R group, which looks like it's a CH2 COO minus, which must be called aspartic acid. So that's our name, and I'm going to just go over here to Spartan and show you what that looks like. So here's this this first R group, which you'll have to look up its name in the appendix, followed by the alpha carbon right there with its NH3 hung off it, and so on. So I think that should be enough for you to finish this and part C.